Excuse me. All right, guys. Well, welcome back. We are in this segment going to take a look at the F block and the P block on our beginning deep dive of the periodic table. Now, before I get into the F block, which I want to do first, I do want to acknowledge one thing. You know how many blocks there are in the D block? Excuse me, how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 elements that can fit in the D block. So here where we have this gap, we need to account for that. And what you should know is since this is element 72, this element should be number 71, okay? If we count across from the beginning of the sixth period, we see 55, 56, and then down here is 57, okay? So 57 actually does not belong in the D block. 57 is part of the F, but over here is 71. So before I tell you more about the F block, I'm just gonna make sure that I get these two identified correctly as D block elements. Now, if you start doing your own research, you may find that there are different chemists who identify different elements for that space. So just be flexible in your thinking and understanding. But in general, we say that there are 10 D block elements. So these two would be represented here. Now we're going to go into the F block. So the F block elements. First, what I can say is that we still consider them transition metals. And so if you were to describe F block elements in some kind of a broad or generic sense, we would still consider them transition metals because they can have multiple oxidation states. But there's something special about these F block elements down here because they are extremely dense. Remember, these elements are relatively soft, right? They're so soft that you could even change their shape with your own fingers. These D block elements, we consider these typical dense, right? So how hard is a coin? Well, a coin is made out of nickel or copper, or sometimes it has zinc in it. So when you think about the density of a coin, the density of your pots, for example, you're talking about these elements. But when you get down here, I mean, you are now starting to put so many protons and electrons together. And remember that the F block elements start on the fourth floor. So you start filling in these electrons on the fourth energy level. Now, when we get to the fourth energy level, and we start filling in all of these elements in order to accomplish the electron configuration, oh man, it gets crazy. Now, let me give you a few things that you need to remember for your notes. Some of these elements are so unstable that they are very reactive. Okay, so this top row has a special name. That special name is the Lanthanide Series. Okay, this element is called lanthanium. You can't blame scientists for being creative. Okay, so this top row, we call these the Lanthanide Series. And this bottom row, if you see the name of this element, number 89, is actinium. So this whole series here is called the actinide series, okay? Now, these elements here, the most popular ones, the ones that one of you will probably do research on, would include plutonium here and uranium. These are two very useful ones that we see a lot. But just keep in mind that the actinide series down here, these elements are dangerously radioactive. And what that means is they are cancer causing. Okay, so when I think about these elements, I think about a scientist named Marie Curie. Now, this white lady was extremely brave and extremely smart. She didn't realize that she was exposing herself to a cancerous element, but she was certainly amazed at the fact that it was warm to the touch. And it's warm to the touch because these elements are actively breaking down. They're so dense, they're so heavy that they're actually unstable on Earth and begin to break down. Okay, and they give off dangerous energy, and that energy, called radiation, can give us cancer. Okay, so this is something that you definitely want to be aware of, and just know that in your normal day-to-day life, you're never going to come across these heavy elements. These are for professional scientists who do this kind of a thing for a living. So what else can I tell you about these? All of these are gray. You don't see any unique colors here. They have your typical metallic character. They're shiny. They are malleable. They can be changed into different shapes and rolled into wires. But just keep in mind, these are ultra dense. That makes them different. They're all gray. That's another unique characteristic. And the ones down here in the Actinide series are so unstable that they're even radioactive, okay, which means they cause cancer. Okay, and down here we also say that they are warm to the touch, okay? They're so heavy that they're warm to the touch, so keep that in mind. All right, let's go on to the P block now. So that would be this section up here. Now for the P block, I saved it for the last because it's actually the most diverse group out of all of the ones on the periodic table. And so because of that, even though I am not going to color them, what I'll do is find a way to get to these another way. Or maybe I am. You know what? Let's live a little. No, I'm not. I'm not going to do that. I'm going to give them all one color. But the reason I'm having such a debate is because they're so diverse. Like, let's just get into it. So first of all, the P block elements, number one that you could write down in your notes, they are the most diverse block. Okay. In other words, all of these are metals and they're all generally soft and very reactive, right? All of these are metals. They might have some different colors, but they're generally dense and relatively reactive. All of these are very dense metals. They're all very gray, and they can be radioactive. So here we can kind of characterize these, but these are so unique and so different that it's hard to come up with descriptions that are appropriate for all of the elements in this block. So what I can do is try to give you a few highlight pieces, and then we can break it down as we move forward. Okay, so some of these, for example, are what we would call mildly reactive. So something like aluminum, for example, is mildly reactive compared to something like fluorine, for example, which is very highly reactive. And some of them are non-reactive at all. So this group here, which we call the noble gases, you should probably write that down. This final column here, this family, are noble gases. They are not actually chemically reactive at all. Or, I mean, you have to do some crazy stuff to get them to react. So that's interesting. What else can I say about the diversity? Well, some of them in this block are solid, some are liquid, and some are gas. Okay, so over here, for example, down here, all of these are solids. Okay, but let's see, iodine is liquid at room temperature. Bromine can also be liquid. And then here, these are gases. Oxygen obviously is a gas. Okay, nitrogen is a gas that's in our air as well. Neon is a gas. So the P block has, they come in a variety of colors. That's something else I can tell you. Some are yellow, some are brown, some are blue in certain circumstances. So there's that. What else can I say? Boy, some of them are metals, right? Aluminum is obviously a metal. And some of them are non-metals, right? Oxygen is a non-metal. We don't breathe metal, right? Oxygen is a gas. And then I think I mentioned already, but iodine is a liquid, okay, at standard temperature and pressure, or room temperature. So this is why it's extremely hard to try to come up with general statements about them. But what that also does is give us a great opportunity to do some interesting chemistry. So we will be spending a lot of our time in chemistry over here in the P block and bonding different metals to the parts of the P block and trying to predict the types of reactions that they participate in. So we're going to get into all of that. But for now, what I want you to do is to the skill that I'm trying to get you to develop is your ability to listen to me talking, pulling out information and putting them here in these notes. If we haven't talked about this, these are the notes that I expect you to capture. So these are the ones for the P block. And if you would color this P block section, and then down here, I have a note catcher for the F block. And then you would please color the F section. Take a picture of your notes and show me what you got, okay? So I'll go ahead and see what else I have to say here about the P block. Like I said, this family is called noble gases. This family here, the fluorine family, are called halogens, Halogens, halogens. And then the rest have the same family as the leader, right? So this all we call the oxygen family, the nitrogen family, carbon family, and the boron family. All right, so these are the ways that you can describe the properties of these elements. And then what I'm going to do is either pick an element and ask you to tell me properties, or I will describe some properties and have you find the element that it could possibly be. So that's where we'll start to have some fun. Make sure that you check the practice problems and study those up. And then we will continue to build. All right, guys, listen, I think I'm done. If you need to, go back and review, listen again, pull out some information. And then when we come together for our live class is where we'll start to exchange information as well as verify how well you did in capturing some good stuff. All right, so that's where I'm at, guys, and I'll leave it here. Peace.